Yes, hello everyone. I'm Cecilia Panigutti. I work as a data scientist for the European Commission, and today I will present our paper. But before starting, while I'm the one presenting the paper, I would like to acknowledge that almost all of the co-authors are here at the conference, so I want to thank them for the many hours of joint thinking that went into this work, and I also invite them to jump in for the Q&A session if they want. So let's start. So let me begin by grounding our motivation. So we know that now algorithms are embedded in most of online digital services. They rank, recommend, filter, flag, promote, and demote content. In practice, they influence what information we see, what products we buy, and what communities we engage with. Okay. But as they scale, these digital services, so do the risks. For some example are the amplification of disinformation, discrimination of minority groups, undermining of civic discourse, and even negative effect on mental health. So in the context of our work, we focus on algorithmic-driven risks that we define as risks associated with the use, design, and functioning of digital services algorithms. So our narrative review is grounded in the EU Digital Services Act, which introduces, among others, a legal obligation to address these risks in the Union. In particular, it mandates platforms with over 45 million users in the EU, or 10% of the population, called VLOPs and VLOSE, to identify and mitigate systemic risks stemming from the design and functioning of their service and its related systems, including algorithmic systems. So this raises a vital question both for the research and practitioner communities. How do we effectively assess the risk stemming from these systems in ways that are scientifically rigorous, practically useful, and how these methodologies can help support the risk management framework of the DSA? So these are the central questions that we try to address in our paper. So we conducted this narrative review of the field of algorithm auditing and developed a taxonomy of algorithm audit study design, which we define as structured plans to investigate risks associated with the use, design, and functioning of digital services algorithms. For each study design, we identified main steps, best practices, and links to different obligations related to the DSA risk management framework. So in comparison to previous work, where most of the classification was done using data collection method as a criteria, so API, scraping, sock puppeting, we organized our taxonomy according to the objective in the overall risk management framework of the DSA. So our goal is to provide a flexible, methodologically sound toolkit for researchers, platforms, and third-party auditors alike. So we identified four main types of audit study design. The first one is the risk uncovering studies, which expose previously unknown algorithmic harms. Reverse engineering studies, which probe how the algorithm works. Interface design studies, which analyze how user interface design choices create or amplify algorithmic risks. And risk measuring studies, which aim to quantify the algorithm impact on a systemic risk. So unfortunately, I only have time to skim through the surface of each audit study design, so I'll focus on the highlights, and I hope you will check the paper. So let's begin with the first category, which is the risk uncovering studies. These are often the starting point of the overall auditing process. It's how potential algorithmic harms comes to light for the first time and gain public regulatory attention. So they typically start as an with anecdotal observation from users in the real-world context, what we call situated use. And from there, the investigation evolves, sometimes through community collaboration, sometimes through journalistic work, sometimes in civil society, into a broader understanding of how system might be causing harm. So under the DSA, this kind of work plays a vital role because it supports Article 34 and 35 by helping to surface risks that platforms themselves may not have identified or that may not have been prioritized. Then we have the reverse engineering studies. And these are more systematic investigation of how the algorithm works, usually to later measure how this functioning impact the observed risk. Researchers do this by treating the system usually as a black box, so they carefully vary input, observe the output, and run control experiment to isolate specific effects. And in some studies, if some internal information is available, like documentation, for example, it becomes what we call in the paper gray box audit. What's key here is methodological precision. So the idea is to formulate hypotheses, design experiment to test that hypothesis, control for confounders, and apply statistical analysis to draw valid inferences. And this type of study are directly relevant to DSA transparency profiling obligations, including Article 26, 27, 28, and 38. But they usually provide also the foundation for further investigation of risks under Article 34 and 35. So the third category is the interface design study. Here the focus shifts, Here the focus shifts from the algorithm itself to the design of the platform. The user interface and the user experience elements that shape how people interact with the system. So these studies ask, how does design influence behavior? And in turn, how that behavior feed into the algorithm outcomes? Think of features like infinite scroll, reaction button, or autoplay. These are not neutral. They nudge users in certain directions, and those patterns of interaction then become inputs for algorithmic decision making. So methodologically, interface design study often involve expert reviews, user interviews, behavioral observations, and they draw heavily on the human-computer interaction design theory. So under the DSA, this work is directly relevant again to Article 34 and 35, which require platforms not only to assess algorithmic risks, but also to examine whether design choices themselves are contributing to those risks. Finally, we come to the risk measuring studies. These studies aim to quantify the impact of an algorithmic system on a specific risk. For example, how much a recommender system amplifies misinformation, or whether the content moderation disproportionately affects certain groups. So these studies are hypothesis-driven. They start with a clearly defined research question, and then use experimental setups like different data collection methods or observational methods to measure an indicator of the risk. So this kind of study is essential for determining not just whether a risk exists, but how severe it is, and whether proposed mitigation measures are actually working. So under the DSA, risk measuring studies are core to Article 34 and 35, and especially important for compliance audits under Article 37. So to wrap up, each of the 4 study designs we've outlined contributes to different risk management processes outlined into the DSA. So the auditing process usually starts with the risk uncovering process, followed by a reverse engineering study to understand the algorithm mechanism, and then a risk measuring study is conducted to quantify the impact of the risk. But what we have proposed is not a rigid framework, but a flexible toolkit, meaning that each of these steps can be arranged in different ways, as we also observed in the literature that we analyzed. So our goal was to offer this taxonomy to give some practical guidance for researchers who want to design impactful studies, for auditors who need to evaluate compliance, and for platforms themselves who are now legally obliged to assess these risks. Thank you.